The distance formula. He's going the distance. He's going for speed. I don't know if you ever heard that song by Cake. Give it a listen. Anyway. We can see here we have a right triangle on the XY coordinate plane. And what we're going to do with this is we're going to figure out the distance between points. Now, basically the distance formula is nothing more than the Pythagorean theorem in reverse. So if you'll see here, we have coordinates here. And this is at 0, 12, and this is at 16, 0. So we know that the Pythagorean theorem says a squared plus b squared equals c squared. And we would say this distance is a and this distance is b, right? So to figure out a, couldn't I say that I can do the y value minus the origin y value, and that tells me that this is 12, right? So y minus y. Also, I can do the same over here to figure out b as the x value here minus the x value here. Well, this works really well when you're on the you have a corner here that is sitting on the origin, right? Our right angle is sitting on the origin. But it doesn't work so well if we move off of that. So we use that formula. So basically what we can derive is that the length of AB squared would equal the length of AO squared plus BO squared. So AB is going to equal the square root of AO plus BO. Well, again, to figure out the length of AO, I would take this x value, 16, and minus the x value here, which is 0, right? It's the origin. But that is also the same x value as that point. So, if I want to create a formula of that, I would say x sub 2 minus x sub 1 squared. And I would do the same for the y's. I'd be adding this together. Y sub 2 minus y sub 1 and square that. And that'll give us the length of AB. In this case, though, we're not just doing this for AB. We're doing this for a distance. D. So, let's go through this a little bit further. Okay, so we could use this to calculate AB equals 20. So basically, to do this in reverse, or without all this work, here's an example where this wouldn't work as well because we are not on the origin, right? So the length of AC in this problem would be, let's say, x sub 2 minus x sub 1. That would be the length, right? And the same with BC, the length would be y sub 2 minus y sub 1. So if we can just, with that way, if we can just take this and take the square root of it, we can find out the length of AB. As you can maybe hear, my allergies are kicking my butt. And there's the distance formula. All right, that last line, delta x squared plus delta y squared. Change in y. Change in x squared plus the change in y squared, take the square root of that. All right. So if P is equal to x sub 1, y sub 1, and Q is equal to x sub 2, y sub 2, or any 2 points, and the distance between them can be found with either formula. PQ is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, or PQ is equal to the change in x squared plus the change in y squared, and we take the square root of all of that. Okay, so coordinate proofs. Those are also known as what we call analytical proofs. All right, and you may select any convenient position in the coordinate plane for the figures as long as complete generality is preserved. You cannot use any specific points. You have to use all variables. And we'll now look at some convenient locations for right triangles, isosceles triangles, and parallelograms. All right, so here we have a right triangle. And wouldn't you know it, the most convenient place for right triangles is with the right angle here in the origin. So basically, they use A and B are our variables. We don't want to use any values. So A and B, or they can use C and D and other ones. Later we'll show you some other ones. So A is the length on the x-axis, B is the length on the y-axis, but you'll see it's the y value, right? And we can do all of our work using algebra to prove geometry, using any right triangle work we want to do with this type of coordinate proof. Okay, so one thing with an isosceles triangle, the first thing we want to do is name the vertex. So we would always name the vertex as AB, okay? And the reason for that is we we know that if we drop an altitude down, if we drop an altitude down, which is poorly drawn there, and we have that situation there, if it's an isosceles triangle, we end up with two congruent triangles. And that this midpoint is going to be at A0. And since this is congruent to this, this has to be double. Alright, so that would be up to 2A0. So that's why they came up with that. That's how that coordinate is established. Now, for parallelograms, A0 is easy, right? It's just this distance here, and we know that this is just going to be A. Now, here's where it gets a little bit, could get confusing. We use always BC here, and the reason for BC is this distance is equal to B. That's your B value. C value is going to be your Y value, and since this is going to be a parallelogram, okay, this distance now from the y-axis is going to be equal to a plus b. It's still going to be on the c coordinate, so that's why we end up with a plus b, c. And now you can do any amount of algebraic work to prove geometric processes or thoughts or theorems. All right, so let's insert some distance formula example problems here. Okay, so if A is 2, 3, and B is 7, 15, find AB. Okay, first of all, the distance formula, while it can be intimidating, I find it to be the, you almost have to really work at it to screw it up. As long as you keep your X values together and your Y, you're fine. So we're going to end up with this to start. Okay. So now I plug in, and it doesn't matter the order. It doesn't matter if anything, because here's what happens. Let's say I start with this one first here and this one second here. And now I'm going to start with this one first here and this one second here. Because we're squaring these, they're going to become positive. So it doesn't matter if it's a negative number in that parentheses. It's going to become positive. And then because we're adding, it doesn't matter if X's are done first or Y's are done first. It only matters is that you keep your X values together and your Y values together. So I'm going to end up with 2 minus 7 is negative 5, and I'm going to square that. And that's going to be plus 5 minus 3 is 12, and that's going to get squared. And what ends up happening is I end up with the square root of 25 plus 144. And that is the square root of 169. And God bless us all, that is a perfect square. That comes out to 13. Don't even have to do it on the calculator. Okay, if D is at 7.1 and E is at 9.9 negative 5, excuse me, if D is at 7 comma 1 and E is at 9 negative 5 and F is at 6 negative 4, find the length of the median from F to DE. Well, first of all, you got to solve for M, and M you have to do the midpoint. So we're going to use, so M is going to be the midpoint of DE. So that's add the X's, divide by 2, add the Y's, and divide by 2. So M is at 9 plus 7 is 16, divided by 2 is 8. And the Y value is 1 plus negative 5 is negative 4, divided by 2 is negative 2. So M is at 8, negative 2. Now, to find the distance of the median, right? So FM. So FM is equal to the square root of, let's be smart Alex here. Let's do the Y's first. So F is negative 4, so negative 4 minus negative 2. Square that. I'm going to do my X values now. 6 minus 8. I'm just going to have some fun with it. I'm not even doing it in order. Oh, yeah, well, it's X, same thing. Doesn't matter. So, negative 4 minus negative 2 is negative 2. And I'm going to be squaring that. 6 minus 8 is also negative 2. I'll be squaring that. So, negative 2 squared is 4 plus negative 2 squared is 4. This gives me square root of 8, which simplifies 2. Square root of 4 times square root of 2, which becomes 2 square root of 2. So that's your final answer for the length of the median from F to segment DE. All right, prove the medians to the legs of an isosceles triangular arc congruent. So the way we work this out is, if you look at how they set this up, I'm going to take and I'm going to find the distance of this segment here using these values. And then I'm going to find the length of this segment here using these values. And I'm going to show that them be that, and they'll come out equally. They should. So let's do the AN first. So AN is equal to the square root of 3a minus 0 squared plus, that's the x values, b minus 0 squared, which is equal to 3a squared. Oh, excuse me, that's a mistake on my part. 3a quantity squared plus b quantity squared. So 3 squared is 9, so the square root of 9a squared plus b squared is equal to AN. Now we're going to do the length of BM. And so I'm going to take 4a minus a squared plus, we're going to do b minus 0 squared. From here I end up with, well, look at this, 3a squared plus b squared. So I end up with square root of 9a squared plus b squared. So